think I can hear you. I'm not sure actually because you're not replying to me. Um, right. Right. Let's start from previous day tutorials. Right. Uh, this one's is the worksheet about that's related to regression, correlation, and chi-square test. Um, so the first question, I'm not sure whether I discussed this or not. Anyhow, I'm starting from this one. Uh, First one, below is a sample data set for the heights and weights of 10 men. Heights given, weights given here. Uh, so draw the scatter plot to the above data. So we can enter the data to the worksheet, SPSS worksheet, right? So this is you can define the variables height and weight. So height in inches, right? So this actually scale variables. Then the first task is we have to draw the scatter plot, then graphs, legacy dialogues, then we have to take scatter, right? Then simple scatter, then y-axis is weight, x-axis is height, right? So independent and dependent variables, then we can draw the scatter plot like that. Mm, yeah, there is a problem. We'll see what is it. Like, wait, wait. Scatter plot is not displaying here. Wait, we'll say check again. Graphs, legacy dialogues, scatter plot, simple scatter, X and Y, okay. Oh, something happens there. We'll see. No, no, no. No, it's okay. Now it's displaying. Right? Yeah, it's two times appearing there. So it takes a little time here. All right, this is the scatter plot then. So by observing this scatter plot, you can see that there is a positive relation, it's actually a positive correlation, right? So this should be, um, yeah, so this is actually not the perfect positive one. So actually, but you can see the positive correlation, right? Because of this trend line, may trend line අපිට හොයාගන්න පුළුවන් මේ පැත්තට ගිහිලා තියෙන මේ පැත්තේ තියෙන positive relationship එක. Right, next question. Use SPSS to generate model summary and coefficients. Right, we'll go next one, analyze. Uh, we need SPSS model summary and coefficients. Interpret the regression output. Okay, so then we have to go for the regression analysis because we need these things. So analyze, yeah, regression, then linear regression, regression, uh, linear regression, right? So dependent variable is weight, independent variable is height. Then statistics, so model fit, we can take estimates, and if you need, we can take that descriptive statistics also. In plots, we can go for plots, right? plots, then we can take histogram and normality probability plots. And then options, yeah, and style. I think stop. But that's enough. Then we can take method, right? Okay. Then we can take as mentioned here, model summary is there. The model summary, okay. Then ANOVA table is there. ANOVA is okay. And coefficients. Here we can see the coefficients. So we need to take these things. Then there are some additional things also. Then we can see here, this is actually normally distributed one. And yeah, so these things also we can take. So then we'll check the outputs again. So descriptive statistics, we can see mean of weight is 176.7 and mean of height is 69.90. 69.90. Right? And correlations here you can see there. Yeah, we so that so when we considering that a scatter plot, we saw that so there is a positive relationship. The value is given there. So where's the value? 0.86. That is closer to 0.9. It means closer to 1. So that is actually a positive relation. That is actually a good positive relationship. So you can see from this value. So that is near to 0.9. And here, so then when it's come to model summary, so you saw that this R square value is 0.740. It means 74% of 74% of the dependent variable is explained by the independent variable. So this is actually a relationship between the independent variable and the dependent variables. So then here when it's come to there, then ANOVA, so A is the dependent variable, B is the predictors, right? So then here actually significant, that is 0.001, this is less than 0.05, that's it means that is a good model actually. Then when it's come to the coefficients one, so you can see here this constant value is negative 449, 1.793, and this yeah, gradient is 8.848. So when we are writing this as regression equation, so how we can write this dependent variable is weight, no, then we can write weight equals negative 440 1.793 plus 8.848 within brackets height. So that is a regression equation, right? So I will show you how to write the regression equation there. Right, regression equation. Hmm, right. Right, we can write the regression equation. Can write the equation of the regression line. Equation of the regression line. Hmm, our dependent variable is weight. So therefore we can write weight equals to weight equals to negative 441 point negative 441.793 plus 8.848 multiplication, what is it, height. So this is the regression equation. It means, so if you know height, so we can find any corresponding weights, right? Again, making up to පුළුවන් ළමයෙක්ගේ කාගේ හරි participant කෙනෙක්ගේ height එක දන්නවා අපිට prediction එකක් දෙන්න එයාගේ weight එක මොකක්ද කියලා. Right, so that is the meaning of this regression line. So that thing you can take from this one. And yeah, so that's enough. You can go to the next question, question number 2. Yeah, so then we can interpret the regression output, determine whether height is significantly predicts the height. Predict, yeah, that is significantly predict. Why is that? So here's the output. Yeah, so when it goes to the model summary, so you knew model summary, this one. So that's model ANOVA. So again, this is actually significant. It means this is uh, significantly predict that. uh, Wait, question number 2. A chicken farm owner tests a feed supplements to increase egg production. The dataset consists of 12 groups of 100 chicken each, receiving different supplement levels. Draw a scatter plot. Yeah. First thing is we need to enter the data, right? So we have group, food supplement, and number of eggs. So we can define three variables: group number, food supplement, and number of eggs. So group number is a nominal variable. Other two are um, scale variables. So then we can enter the data on up to 12, then number of food supplements and number of eggs. This is there. Right. Then what we'll see what are the questions here. Draw a scatter plot. Yeah. So we can draw the scatter plot to these two variables. So what are the variables? Feed supplement, and number of eggs. Then we can go graphs, legacy dialogues, scatter plot, simple scatter. Number of eggs is dependent variable. Food supplement is. Then you can see here. It's very difficult to predict here. So make a banana, make a judge. We can see there is a positive relationship, but it's very hard to take the number which kind of then make a godak look on the relationship the number. So previously we got 0. කලින් එක අපිට ආවා in previous one and අපි කලින් එකේ බලමු regression එක මෙන්න මේකේ so මේක අපි කොහොමද හොඳ relationship එකක් තියෙනවා කියලා regression sorry correlation correlation is 0.86 ඒතර අනිවාර්යයෙන්ම මේකේ correlation එක ඊට වඩා අඩු වෙයි because of this මෙන්න මේ pattern එක බලපුවම අපිට ඊට වඩා අඩු වෙයි කියලා අපිට පේන්න තියෙනවා right so then so the null hypothesis and alternative hypothesis, right? SPSS to generate model summary, SPSS and ANOVA. We have to take that also analysis, regression, and linear. So a number of x dependent, feed supplement independent, descriptive statistics we can take, and plots. No need. Yes. You can see mean number of x 87, and mean number of food supplement is 17.5. And Pearson correlation. So here I told you, the make a band is got a card. What is a Pearson correlation? It's near to 0.5. Right? It showed. Then when it's come to the model summary, the R square value is 0.249. It means 24.9% of dependent variable is explained by the independent variable. Actually, this is not a very good model. මේක predictions වල හොඳ model එකක් නෙමෙයි. ඇයි ඒ? 124යි predict කරන්න පුළුවන්. right? එතකොට මේක ඇත්තටම predictions වල හොඳ model එකක් විදිහට අපි සලකන්න බෑ කියන හරි උත්තරේ එන්නේ නැති වෙන්න පුළුවන් as real වගේ හැම උත්තරෙම හරියන්නේ නැහැ. මොකද මේකේ model summary එක තියෙන. මේ කියන්නේ මේකේ power එක මදි. මේ model එක එච්චර හොඳ model එකක් නෙමෙයි. ඒතකොට predictions. Right? So anyhow that so here we can see. And yeah, so this is actually again significant. Then when it's come to the coefficients, we make a gamu. So dependent variable is number of x. So we can write here, then we can write here number of x. Number of x equals to number of x equals to 77.267 plus 0.8580 feed supplement. supplement. So this is the regression equation. This is a regression equation for both. Right. Question number 3. A psychology student examines the long-term effects of alcohol on reaction time by measuring the responses time and self-reported alcohol consumption per week. Alcohol consumption units and reaction time is mentioned there. Draw a scatter plot. Compute the Pearson and Spearman correlation coefficients. Interpret the correlation results. Explain whether alcohol consumption significantly affects the reaction time. Yeah. Then alcohol consumption units and reaction time is given there. So we have to do the correlation analysis here. Right. So right. First thing is we need to enter the data. Alcohol consumption. Alcohol consumption units. So reaction time. Reaction time in milliseconds. Both are scale values. Then we can enter data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 16 is the higher. Yeah. No, it's okay. There are 50. Right. Then questions, draw the scatter plot. Then we can go to draw the scatter plot. Yeah, we know how to draw the scatter plot. We can go analyze, sorry, graphs, legacy dialog scatter. Yes, again we can see there is a positive relationship on අපි හැඩය බලලා මේ select කියන්න පුළුවන්. So previous one 0.86, next one 0.499. So then this is actually so based on this shape we can predict that so this value is greater than 0.5 and less than 1. Right, actually 0.9 මේ දෙක අතර තමයි තියෙන්නේ. Right, අපි බලමු ඇත්තටම මේ observation එක හරිද කියලා by the values. Okay. And computer Pearson and Spearman's correlation. So analysis correlate by variate. So Pearson and Spearman both we need. Then variables these two. Then here I told you. So 8 points 0.86 value. What is value? 0.809. Right? Then it's greater than 0.5. Right? So correlations දෙකක් තියෙනවා. One is Pearson's correlation. Pearson correlation 0.805. Then it's non-parametric correlation. Spearman's correlation that is 0.809. So there is no big changes actually. Right? If you use any method, so sometimes little but that is similar actually. So but so suppose that so the non-parametric tests are not valid than parametric tests. Question number 4. The data set below examines how the study habits, sleep duration, and exercise routines influence students' academic performance. Here, that is actually a special question. So here, if you read that question, we can understand. So there are three variables actually, four variables. One is study habits. Then actually study hours actually, how study hours. Second one is sleep duration. Third one is exercising hours, and the other variable is exam score. Then first three, study hours, sleep hours, and exercise hours, these three are independent variables, and last one is the dependent variable there. So in actually, yes, so we'll see that. Right, question number 4. Right, next question. Right, so then we have to enter this data. Before enter, we have to make variables, right? Variables to type, sex, and count. Right? Questions. Oh, not this one. I mean, questions. Give me 1 second, right? Make open and right. Here we can enter the data. We make a data enter කරන්න පුළුවන්, right? So, right after entering the data, you can see like this. Data enter කරන්න පුළුවන්. Then we need to find calculate mean, median, and standard deviation for everything, right? Calculate mean, median, standard deviation. It means descriptive statistics. Then we can check. Right. So we can go analyze descriptive statistics. Explore. Dependent list is exam score. And independent, there are three. All of these are independent. Then this is the summary actually. Then they ask the descriptive statistics. What are the descriptive statistics? Ask it. Right. Actually, it's not. Right. We'll first need a descriptive statistics. Now again, I am going here. analyze descriptive statistics, we go for the frequencies, right? So we need to take this all, what are the variables we need? Calculate mean, median, study hours, sleep hours, exercise hours, and exam score. All four variables are there. All four variables are there. Then we need to find what are the needed statistics here we have to take. We need more mean, median, and standard deviation. Only these three: mean, median, and standard score. Standard deviation. Right. Then mean, median, and standard deviation. Right. Mean, median, and standard deviation. Then okay. Let's see the output. There are frequencies. It means separately here, and study hours. You can see the frequency table, how it's divided. Then sleep hours. Yeah, then exams it's mentioned there. Right. Second question is that compute the correlation coefficients between the study hours here. And next one, compute the correlation coefficients. Then we can go analyze, correlate by variable. Yes, again we have to take these all four variables. Correlations, yeah. These are the correlations. But under this one, okay, negative. The next question. Perform multiple linear regression with exam score as the dependent variable and study hours, sleep hours, and exercise hours as independent variables. So in here, there is this is actually multiple linear regression one. So the previous questions, that is that you have only one independent variable and one dependent variable, but there is this one is actually different than those because there are three independent variables for a one dependent variable here. That is what we have to perform multiple linear regression here. Right. We can try that. Right. Then we can go analyze, correlate, variable. Correlations, okay. Next one. Write the regression equation. Okay. Regression equation we have learned. Therefore, we can go analyze regression, linear regression. Dependent variable is exam score. There are three independent variables. Right, coefficient table is also there. Right, the thing is that so we need to write the regression equation here because they have three independent variables for one dependent variable, right? Then we can write regression line. We can write regression line. We can write yeah. Dependent variable is exam score. Then you can write exam score equals. Then we can write the dependent variables, the coefficients one. Then constant is 53.043 plus 3.117. 3.117 times study hours. Study hours plus right, next one study hours. Okay, then 2.121 times then 2 point sleep hours. And finally, right, so this is actually I don't know whether this is correct. Then, yeah, but then another one exercise hour. 1.433 times exercise hours. Right. So if we have yeah, so then this is how we can predict, right, the equation of the prediction lines. Next question. There are some questions there, so we can answer the questions. Just the following table represent the gender and job type. Random sample of the supermarket employees. Supervisor, staff till pale female is there. Compute the expected frequencies. Assume there is a small. Yeah. Right. We can write chi-square test we have to do, ne? Right. So then this is how we can enter this one, right? So then here mentioned 1, 2, 3 is there. So 1 is for supervisor, so 2 is for self-taker, and 3 is for till operator, and 4 is for clean. And here also 1 for female, male, so 2 for female, right? chi-square test. Then analyze descriptive statistics. Analyze data. Chi-square test. Analyze descriptive statistics. First steps. Then right before forming this, we have to data weight cases, not select cases, weight cases. Data weight cases, weight by count. So we can perform the chi-square test. Then we can go analyze descriptive statistics, then cross steps. Then rows, job type rows and six columns. Chi-square will be needed, and this is the output, right? Then last question. Yeah, this is last one. The survey of supermarket employees recorded their attitudes towards the wage resistant based their job type. Yeah, right. We can enter the data. We need job type and job type and yeah, wage resistant, right? Wage resistant. So then we can take variable view, uh, job type, job type, and Next one is wedge resistor. Then there are three, actually four in here. Job type, uh, label, values. One is for cashier, cashier. Two is for cleaner. Three is for manager. Four for stocker. Stocker. Right, it's okay. Then it's okay. Okay, then for this one again, uh, one is neutral, oppose, support. One neutral, two oppose, three support. Then we can come to the data view. Then we need another one variable called count. Next one, count. All scale variables. Right. Then we can enter data view. Job type, yeah. Cashier, cashier, neutral. It means 1, 1, 20. Then cashier oppose 1, 2, 90. Likewise, we can enter the data. Right. Then we have to enter count 24, 19, 11. Only three, no? Yes, we divide or define for three. Only four is not there. And next one, 15, 28, 50, 23, 27, 11, 12, 25, 50. 12, 25, 50. Oh, no, that's true. Right. Then data, weight cases by count, weight cases by count. Right. Then we can set up the contingency table, chi-square, determine. Okay. Then we can go for chi-square test because that is actually a frequency. Then you know that how we can apply. Then we can go analyze descriptive statistics, cross steps, cross steps. Okay. Then rows. In rows we have this one. Columns we have job type. Then we can go exact nothing. Then statistics, chi-square we need, and cells we need expected values also. And that's all. We can take this. Yeah, then chi-square test is there. So that is significant. Yeah, the chi-square value is 53.312. Likewise, we can do conclusions. The conclusions can pull up. Right, so that is about the last session. Last session, Nikayaka. Right, then we'll go for a new one. So, Rapi, other body, this is actually so practical. Okay, so then today we are trying to discuss about the exploratory factor analysis brief, right? Briefly. So these are the learning outcomes. At the end of this lesson, you will be able to understand the purpose and applications of factor analysis, differentiate between PCA and component factor analysis, the common factor analysis, then perform PCA in SPSS and interpret key findings, apply principal axis factoring and maximum likelihood, use Varimac and direct opt-in rotation methods, generate and interpret factors scores for further analysis, and apply factor analysis techniques to simplify data and identify key patterns. Right, introduction, motivate an example. Right, you see here, mm, this is actually there are 8 items in a this is XPSS and site. These are the observed variable, and this should be the latent variable because we can't directly observe the end site. So there are many questions. So from that scale, we can measure the end site. Okay. So then that is actually a question, yeah, the kodasakti. Suppose that is actually a sample question, yeah. So there are 8 questions there, yeah. I dream that person is attacking me in correlation coefficients. I don't understand statistics. I have little experience with computers. All computers hate me. I have never been good at mathematics. My friends are better at statistics than me. Computers are useful only for playing games. I did badly at mathematics at school. Right? So this is a question and the questions in the questionnaire actually. Right? Questions in the questionnaire. Then Pearson correlations. Yeah. So we'll try to find the correlations. Pearson's correlations. Right. Right. Yeah. So this is actually Pearson's correlation. So you know how to find the correlations, right? So it's mentioned there. So, statistics makes me cry, and yeah. So the correlations are there. So then here we can see large positive and large negative correlations here. We can observe those things, right? So actually, here we'll try to get. Then this is actually the question I entered that actually that's a practical question. There are 7,2,575 one. දෙදස් පන්සි හැත්තකක් data enter කරලා තියෙනවා මේකට. That is what we uh, what you call that is what we expected, I think, right? So then we'll try to do these calculations actually, right? Right, අපිට only the correlations, but analyze, correlate by variable. Right, we need to take all of these variables here. Then we need to calculate what? Yes, these are the correlations. So you can see here, minus 0.99. It's here, right? Then negative 337, right? Negative 318. Okay, all the things mentioned there. So this the thing we can find here, right? So the existing Pearson's correlations. The next one is actually, so there are two things we have to remember: that common variance, unique variance actually. So the common under the common variances, we can calculate commonalities, right? Right. Actually, then here you can see that thing we discussed actually. But may තියෙන latent variable එක. So then these are the observable variables. So මේ තමයි questions දීලා තියෙන question එකේ. So by combining this all, we can find this actually latent variable, that is SPSS and anxiety. Then fact extraction. So here we can, there are many models, that is exploratory factor analysis and principal factor analysis. So yeah, then they can rotate actually also these factors. Right. Principal component analysis. So we take this actually the output, right? We are outputting up correlations that the right. So actually these are the correlations. Methane A correlations, right? May A correlations ටික මයි තියෙන්නේ, right? මේ හොයාගත්තේවමයි බලන්න බලන්න compare කරලා, right? So these correlations are there, right? We got this PMN's correlations. Right. Then we can find the eigenvalues. Eigenvalues are the uh, yes. Then eigenvalues. Then next one is yeah. We can go for the fact analysis actually now. Right. Fact analysis will go then. Um, then we can go actually analysis dimension reduction factor. Analysis dimension reduction fact analysis. Fact analysis. So we can select all. Then it's come fact analysis. Okay, then we can go from method. Yeah, we can go for the method. It's mentioned principal component analysis, unrated. Then scree plot we have to join row here. And fixed number of factors, we can take 8 factors. The number of it, maximum number of iterations convergence for 100. Yeah, then we can take this. We'll try to take the output. Yes, this is the output. 38.206. Yes, then we can find the communities. Communities means square of this, uh, what you call, Minimake. Communities can minimake a square, right? So this is the correlation. So if we take the square of this, right, we can take like that. Then taking all the square, these communities, if we add, we can find the eigenvalue. Here, the eigenvalue is it's mentioned there. So that is how we can find the eigenvalues. Sum of the squared loadings, right? So if you have any questions, so stop me and ask it, right? Then this is right. So this is mentioned that how we can find these commonalities. And after, then you have these commonalities. So if we add this whole, we can take the eigenvalues. So the sum of the squared loading was downwards. When you make a square correlation का square करा हम community sum पे ना. So then if we add these commonalities, so we can take the eigenvalue. Okay. Then it's mentioned then here 30.1.006. That's for those things we can take, right? And yes, total variance. Then these are the communities actually. And it's come to this table. මේ table එකට අපිට එන්න පුළුවන්. Right. So this is that table. We can see total variance explained. So this is 3.057, those things there. And extraction sum of the square loading source remains as same. Right. And scree plot. So you can here we can take this scree plot. Right. Y is eigenvalue is greater than 1 in private area. So then this you can see this L O. Since community is 1, principal component analysis. For a single item, the eigenvalues greater than 1 explains the combinative for more than 1. Okay. Then we can go for the principal component analysis. For it up young. Next. Right. Then made two components. So it's among 8 components altogether. Then now we need 2 components. The only thing difference is we have to change there. Right. Again, I'm trying to take that. Analyze, analyze, dimension reduction, factor analysis. Right. That's all that the thing is that we need to change the method. Sorry, not the method. Fixed number of factors. 8 to 2. Right. All the others remain same. Right. Right. So then we can take this 3.057, then 88 point, okay. Then here we have 38 point, then this one. So then the eigenvalues there. 84% of the dot variance in the item to explain by 1. Why it's like that? Okay. Then extracting factor from the principal component analysis we discussed. Next one is common factor analysis. Common factor analysis we'll try. What is factor analysis? Okay, so actually what is factor analysis means that Samalat, when we are creating the questionnaires, okay, so we don't know how it's related with the other items. So the other thing is, so අපි questionnaires හදුවාට, so we have to check that whether it measures what we intended to අපි හිතපු දේම දෙකකින් වෙලා තියෙන කියලා අපිට question එකකින් අපිට බලා ගන්න වෙනවා. සමහරවිට අපි එහෙම හදුවාට it's not නේද? ඕන විදිහට එන්නේ. So these are the observable variables and this is actually latent variable, right? Right. So we'll go for this one. Mhm. Shall do. This is communities. This one. Yes, the total variance explained that, so I discussed that. So then next one, and we can go for that eigenvalues. සමහරවිට අපි මේක දැන් ඉස්සර fix විදිහට අපි හිතලා බෙදපු එකක් කරේ. So sometimes we can't what do you call separate like that. So then we can separate based on these eigenvalues, right? So eigenvalues are only for the PCN, yet eigenvalues are eigen user side only for PC, a principal component analysis, right? We'll see. Yeah, right. Next one we can check that principal axis factoring, right? We can go then analyze, compare means, sorry, analyze dimension reduction fact. Then we can go for the model. We have to check this principal component to principal axis factoring, right? Then factors to okay. Then okay. 0.847, yeah, it's okay. So then we can come to here. Yes. Yeah. factor matrix and everything is there. So then it's divided to factors as well. මෙතන දෙකකට බෙදලා අරන් තියෙන මේ factors from the factor analysis. So because it mentioned two factors extracted. Okay. Next one is again principal axis factoring. Yes, we'll see then. Principal axis factoring වලට අපිට යන්න පුළුවන් මෙහෙම, right? Then communities. So again, same one, same thing. We can find these communities as well. So then we can go for another one, uh, maximum likelihood. So how we can do this, we'll see. Then again, we can have to go analyze dimension reduction, factor analysis. So now the method is maximum likelihood, maximum likelihood method. Then we can take the output. Yes. Right. So then here chi-square value is 0. Then I wanted to explain that then it's divided into three, here like two, like. So in here, what we are doing is then like, why we are using this confirmatory factor analysis actually. So you know that sometimes we are creating the questionnaires and the other things, but we don't have chance to evaluate those questionnaire and the other things. Therefore, that we can use the factor analysis, right? Factor analysis. So then on the factor analysis, so we discuss about that these three, two actually, what is principal component analysis, then uh, principal axis factoring, and the other one is this. That is mm, this one. Right, then we'll let's discuss some of the few about these rotation methods. Right, some rotation methods also we can use. Right. So this is a question. So then here. So we here it's divided into four factors නේ. මේක factors වල නිකම්ම වෙන් වෙලා තියෙනවා. ඒතර මේ so අර අපි තිබ්බ රූපෙ තිබ්බකෝ. Right, likewise මෙන්න මෙතන then SPSS anxiety likewise the total variance explained, so likewise it's divided. So okay. එතකොට අපිට that's what I wanted to discuss with throughout this uh, course, right? So actually before finish the course, so I want to know something that so if you learn something and if you have any problem, right? So if you need more clarifications for the some areas, so we can discuss, right? Yeah, anything to say? No, Abhilash, Yumi, Indureka. So do you need to clarify more because we are going to stop from here? Clarify more, or do you need to yes? මොන හරි කමෙන්ට් එකක් දෙන්න තියෙනවා නේ ඒකට chance එක. No, so understood. Where the others? Any questions? Right, if you need actually further assistance, right? I don't know whether so when you are doing so, yeah. So most of you are research students, no? Right, most of you research students because I asked you at the beginning of the course. So when we are when you are analyzing again, do you have any? If you met any question, so you can ask You can send that to your your institution's group. Then they will forward to me, so then I can help you actually. Well, then if you don't have any questions, right, we can stop from here. That stop means that course is stopped, right? Course එක ඉවර වෙනවා, but so if you have still questions, you can. It is open to ask that. Okay, then good luck with your research, right? Bye.